Right. Which one among the following are good oxidizing agents? Samarium plus 2, cerium plus 2, cerium plus 4, terbium plus 4. So here concept is what? Always oxidizing nature. Oxidizing nature. Directly proportional to oxidation state. So here, whenever you take because especially lanthanoid and actinoids, they belong to third group elements, general oxidation state plus 3. More than plus 3 whenever it is there, because generally they exhibit what? Plus 3, plus 4, plus 5, plus 6, plus 6, plus 7. Actinoids, lanthanoids, again, actinoids plus 2 also there. That's why you have to consider these lanthanoid actinoids. They have variable oxidation state like D block elements. Generally, whenever you take the oxidation state more, because here also terbium and cerium both are correct. C and D. C is the answer. What is the number of unpaired electron in the highest occupied molecular orbital of the following? Nitrogen, highest orbital. If at all you write, this is nitrogen, we can easily say that. This is the 14 electron diagram. Now here this is what? 14 electrons. 2, 2, 4, 6, 8, 10, 12 and 4. This is a 0. N2 plus. N2 plus, that is what? N2 plus means 1. Generally what? 1 electron is removed. Then definitely what? 1. O2. If at all you write O2 general electronic configuration. Now here 16. This is the 1. This is the 1. Again, highest occupied. This is a 2. Again, if at all electron is removed, then it is becoming what? 1. So here, what we write here? 0, 1, 2, 1. So answer is what? 1. Which of the following cannot be explained by crystal field theory? The order of spectrochemical series, magnetic property and transition metal complexes, color of metal complexes, stability of the metal complex. These 3 are very important properties of the crystal field, especially crystal field. CFT has been introduced to know the paramagnetic nature of the complex. Second thing is the stability of the complex. Third one is what? Again, magnetic properties also. But here, spectrochemical series we cannot. The order of spectrochemical series is not based on crystal field theory. Okay. So this is answer. 1 is the answer. A student has studied the decomposition of gas AB3. AB3, this is obtained the following data. He obtained the following data. The pressure mm mercury, that is 50, 100, 200, 400. Here 4, again 2, 1, 5. This is very simple. By seeing this then we can say that this is a T of is inversely proportional to A. That is called second order kinetics. By seeing itself we can say that is we can tell the answer. But if at all you want interpret the generally this one, but directly we need not actually spend much time for this. Again, if at all you want write this, we can also, because already have done this problem. So this is T of is this is a T of 1 by T of this 2. This is a P naught 1 by so that is equal to 4 by 2 is equal to. We can do this way also. But without using that also, directly we can write this. Is actually does not take much time also. It is inversely related. So otherwise we can do the formula orientation. We can do this. Right. The number of s electron present in an ion with 55 proton in its unipositive state. Unipositive state, this is the 55 means what? 55, generally what? We write like this. 55 minus 32, this is the, directly I write like this. 55 minus 18, this is 37, minus 18, 19. So, lithium, sodium, potassium, rubidium. So, this is a 3, this is 11, this is the 9, this is the 19, this is a 37, this is about 55. So, here 1s2, 1s2, 2s2, 3s2, 4s2. This is what lithium. 1s2, 2s2, 3s2, 4s2, 5s2. That is what, again, let us write like this. This is the first group element, right? 1s2, 2s1, 2s1, 3s1, 4s1, 5s1, 2s1, 3s1, 4s1, 5s1, 6s1. If this electron is lost, then how many electrons are there? 1s2, 2s2, 3s2, 4s2, 5s2. This is what 10 electrons. Okay. In which of the following reaction the hydrogen peroxide act as reducing agent? Hydrogen peroxide act as reducing agent. Reducing agent means it must undergo oxidation. This is what? -1. This is 0. So it has undergone oxidation. So HOCl, HO minus Cl plus. Cl plus 2, it has been changed to Cl minus. Here only taking, because this is what? -1. This is minus to undergone reduction. This is undergoing what again? Oxidation. So it is acting as reducing agent. Third one is answer. Without doing anything else, we can tell the answer. Right? For this one, actually much knowledge is not required. Because -1 to 0. Undergone oxidation means it is acting as reducing agent. Cl plus, this is what Cl. It is undergone reduction. So that is acting as oxidizing agent. The metal which is extracted by oxidation subsequent reduction from its ore. This is the what? Again silver. Silver generally what? It is going to be like this. Now if at all you see the reaction, that is what? 4Ag plus 8Cn plus oxygen plus 2H2O. That is equal to 4Ag Cn plus 4OH minus. So this equation we can easily explain. So it is a silver, the metal which is extracted by oxidation and subsequent reduction from its ore is what? Silver. Right? This is only by hearting question. This is, it has no any proper significance. Now this is a very important. What he has given, you try to understand. The given below two statements, statement 1, again amide 1, 2, 3, 4. 1, 2, 3, 4, 4 oxo. Again, this is the pentanamide. Under Clemmensen reduction, conditions will give. Clemmensen reduction will give, that is, this is this Clemmensen reductions, that is zinc amalgam by concentrated HCl. Clemmensen reduction conditions will give this. Okay. Statement 2, under Wolff-Kishner reduction, condition will give. So this is wrong. Because Wolff-Kishner reduction, hydrazine by OH minus. Hydrazine by OH minus. So generally what happens, whenever the base is there, it undergo dehydrohalogenation. So dehydrohalogenation, this is the wrong statement. So Clemmensen reduction, zinc amalgam by concentrated HCl, because that is acidic. Even you take a hydrolysis, that is the, so this is okay. Both statement 1 is the true, but statement 2 is a false. Third one, because this is going to give but here alpha, 5 alpha hydrogens are there. Alpha, only 3 alpha hydrogens. So this is the more dominant. So that's why, but anyhow, it undergo dehydrohalogenation. Statement 1 is the true, but statement 2 is a false. Okay. Clemmensen reduction will give zinc amalgam by concentrated HCl. That CONH2 also going to be hydrolyzed. and giving what? Carboxylic acid. Given below the two statement, one is labeled as assertion and reason. Beryllium has large hydration energy due to small size of beryllium plus 2 but relatively large value of atomization of enthalpy. In the light of the above statement, choose the most appropriate answer from the option given below. A is correct but R is not correct. But both A and R correct. R is the correct explanation of A. A is not correct but R is correct. Both A and R correct. R is not the correct explanation of A. Assertion: beryllium has less negative value of reduction potential compared to the, because here try to understand, SRP value is equal to enthalpy of sublimation, enthalpy of ionization plus enthalpy of hydration energy. Whenever you are taking this SRP, this is heat of sublimation. Enthalpy of ionization. This is what. And beryllium has really small size. Because small size is there, it will have the more heat of hydration. But here, atomization enthalpy is what? Larger. That's why net value is going to be changed. So that's why both A is not correct. Both A and R correct, and R is the correct explanation of A. 2 is the answer. Right? Okay. So this is anti-fertility drug, tranquilizer, antihistamine, antibiotic. So anti-fertility drug, that is what only, that is the norethindrone, that is correct only. If at all you see this is a tranquilizer because sleep inducing medicine, equanil, again meprobamate, that also correct only. Even equanil, that also best medicine for tranquilizer. Whenever the person is having depression, generally it's in order to make them to get sleep. Generally we are using what? Sleep inducing medicines, tranquilizers. That is the antihistamine, Seldane. This also correct. It's only purely chemistry in daily life. Antibiotic, ampicillin. Ampicillin, this is what spectrum? This is A1, B2, C3. This is only 4. This is only by hearted. You should remember this one. Because generally what in IIT, this kind of question, because IIT aspirant generally they do not have much interest to by heart all these things. But anyhow, you have to do this. Otherwise, you lose 1 mark. So that definitely in chemistry and daily life, you have to write, you have to practice, you have to buy some of the things like this. Okay. Benzene is more stable than hypothetical cyclohexatriene. That's correct. The delocalized pi electron cloud is attracted more strongly by nuclei of carbon atom. In the light of the above statement, choose the correct answer from the option given below. A is the true, R is the false. Now, whenever you take this into the consideration, the delocalized pi electron cloud is attracted more strongly by nuclei of carbon atom in the light of the above statement. Generally what? Whenever you take, this is the, generally what? Cyclohexatriene will not be there. It is not hypothetical. Because here probably this is going to be delocalized here. So benzene is the more stable than hypothetical. This is correct only. The delocalized pi electron cloud is attracted more strongly by nuclei of carbon atom. Because generally a delocalized pi electron cloud is more attracted more strongly by nuclei of carbon atom. So this is generally what? Whenever you take the electron cloud, both A and R correct, and correct R is the correct explanation of. This is the correct. This is a very simple question. Okay. Because whatever the number of pi electrons are there, all those pi electrons are being attracted by the what carbon. That's the bonding orbital, right? That's why both are the statements correct. But cyclohexatriene will not be there at all. It is not hypothetical. Choose the correct representation of conductometric titration of benzoic acid, sodium hydroxide. If at all you write a benzoic acid is a weak acid, 100%. Undergoing what? Weak ionization, benzoate ion and H plus ion. Again, sodium hydroxide is the strongest base, Na plus and OH minus ion. So here first one, conductance and sodium hydroxide, because whenever you are adding what? Benzoic acid and this NaOH, it is understood that NaOH, generally what happens? Now, whatever H plus ion is there, this is a weak acid, this is a strong base. So, we are going to have pH, this is a COO minus Na plus, this is the, what? This is the simply salt. Salt of strong base versus weak acid is strong only. Salt of strong acid versus strong base. Salt of strong acid versus strong base, strong electrolyte. Salt of strong acid versus weak base, strong electrolyte. Salt of strong base versus weak acid, strong electrolyte. That's why whenever the weak acid is going to be converted to strong electrolyte, that's why this cannot be correct. Because whenever salt is formed, generally what happens? H plus ion replaced by sodium ion. So first of all, what happens? It decreases, but is a constant. It is not at all correct. Now here, this is what? Again, this is slowly it has been decreased. This is what? Because H plus ion simply replaced by sodium, because here decreased. H plus ion, this is what? Minus charge. So decreased, it has become salt. Whenever it is there, as generally what? This is going to be what? Benzoate, sodium benzoate. As long as this is going to be dissociated, because the strong electrolyte that's going to be formed. Now once it is there, because this is the equivalent point, and that is over. When neutralization is over, the sodium hydroxide is added. The sodium hydroxide is strong base, so that it is going to be what? Abnormally increased. It is going to be abnormal increase. That's why this is only correct. Second one is the correct. First one is not correct. This is a strong acid versus strong base. This is a strong acid versus strong base. This is nowhere. But whereas here, generally what? It is the salt. Generally what? Conductometric salt is a KCl plus AgNO3. This is called AgCl plus KNO3. K plus NO3 minus. K plus NO3 minus. So here, generally as long as actual KCl and AgNO3 added, salt is added, is maintained constant. One neutralization point is over. When KCl is added, if instead of using the what NaOH, if KCl is added, this is the graph meant for the salt. This is graph meant for the strong acid versus strong base. Strong acid versus strong base. But whereas here, this is the only second option is absolutely suitable for that. Right. Find out the major products from the following reaction. That is the 1, 2, 3, 4. This is CH3. This is CH2. This is C. Again, this is there. Now, oxymercuration, demercuration. That is what, again, oxymercuration. That is what hydroboration, oxidation. So, in hydroboration, oxidation, generally what happens? BH3 is there. BH3 generally what? It is not possible. Generally what we have to write? We are not supposed to show BH3 like that. B2H6 in tetrahydrofuran. That we have to show. Then B2H6 had ultimately converted to BH3. BH3 is there always boron. BH3, boron is going to attack the carbon where less steric repulsion is there. Anti-Marconic of addition. Anti-Marconic of addition generally what? CH3, CH2. Then C, CH3. Again CH2. Then B. Again hydrogen, hydrogen. There is a 4-membered transition state is there. Now immediately that's going to be converted to now CH3, CH2, CH3. This hydrogen coming from what? Again this. That's why it is a cis addition. Cis addition. Now CH2 boron. Again hydrogen, hydrogen. Still 2 more molecules can be taken into consideration. I can take 2 more molecules. Now CH3, CH2, CH3, hydrogen. This on hydrolysis always less hindered carbon. Wherever boron is attacking on the carbon, that is converting into what? OH on the base of oxidation. Again, less hindered carbon is going to be converted to CH2C, CH3, CH, CH2OH. Now this is going to be what? It is absolutely, that is a CH3, CH2, CH3, hydrogen, CH2OH. Cis addition, anti-Marconic addition. The same time, whenever you are adding with mercuric acetate, sodium borohydride, if at all same thing I am going to write. But that is a different one, but is a Marconic of addition without rearrangement. This very important thing is second reaction. I am taking what? Same. CH3, CH2, C, CH3, double bond, CH2, mercuric acetate. This is going to be out. Now here, whenever mercuric ion is there, this mercuric ion is going to attack according to anti-Marconic of addition. This is electrophilic addition. Whenever mercuric ion is formed there, because of high effective nuclear charge, these two carbon atoms possessing what? Partial positive charge, partial positive charge. Whenever it is there, generally what? Whenever it is added to the, generally water, again this water, again go and attack here. Then what happens? Followed by reduction. Then what happens? Marconic of addition. Because nucleophile attacks trans, this is a trans addition. Attacks, this is the OH. This is the CH3. CH3, this is a Marconic of addition without rearrangement. Without rearrangement. Because here, whenever the mercuric ion is there, bridged mercury carbocation is formed because the partial positive charge is there. This positive positive charge will not allow to undergo rearrangement. That's why, so here because of formation of the partial positive charge, because of formation of the bridged mercury carbocation, that's why the coming nucleophile is going to attack at the more stable carbocation, and moreover, that partial positive charge ion is not going to be what again, that is shifted or rearrangement is not going to be happen. So you will be getting what? Marconic of addition product, but without rearrangement. This is the anti-Marconic of addition with cis arrangement. Okay. So answer must be, that answer must be what again? This is the example, this is not given. So that is 1. Because that is somewhere array is 1. That's why again I gave the mechanism, you simply see that. Very, very important. Correct statement. The average human being consumes more food than air. An average human being consumes nearly about 15 times more air than food. An average human being consumes equal amount of food air. This is the, only you have to remember this. This is a directly question which is the by-hearted theoretical one. Pure aniline and other aryl amines are usually colorless. Aryl amines get colored on storage due to atmosphere reduction. This is wrong. A1 is correct, because correct, second one is what? Again atmosphere oxidation, but not that one. It is a statement 1 correct, statement 2 is incorrect. Aniline and other aryl amines. Aryl amines means what? Whenever there is a NH2 group directly attached to aromatic system. This is aryl amine or aniline. Aniline means what? In the Portuguese, this is the indigo. So this is the aryl amine. Aryl amine get colored on storage due to atmospheric reduction. So this is not correct. It is atmospheric oxidation. Generally what? They gives color. Which of the following will undergo deprotonation most readily? Basic medium. So deprotonation directly proportional to acidic character of hydrogen. Acidic character of hydrogen directly proportional to minus effect. So A is a possible. So here generally what? This is a concept. You try to understand this. The basic philosophy understand. This is what? Minus effect. This is the minus effect. But these two electron pair plus mesomeric effect. This is a plus mesomeric effect. Plus M group. Plus M group. Plus. That's why basic medium. So basic medium, what happens? This is normally called as what? This is called inductomeric effect. In presence of basic medium, if at all hydrogen is abstracted very faster, or in the enhancement of the inductive effect, in presence of basic medium or foreign group is nothing but inductomeric effect. So A is the answer. Choose the correct color of the product for the following reaction. Oh, this is somewhere. Correct structure, 1-of-ethylamine. So this also, but logic you have to understand very properly. 1-of-ethylamine. Okay. Then what is our procedure? This is normally we can write like this. So that is going to be what? This is released as N2 plus SO3H. Electrophilic substitution reaction. This electrophile generally what? Go and attack here. Because here other azocoupling reaction this is formed. Azocoupling reaction generally para position is generally it is already there is a bulky group is there. This is what this can attack para rather than this because the electron repelling group is there. Rate of azocoupling. Rate of azocoupling. Directly proportional to electron withdrawing group in diazonium salt. Electron repelling group in other coupling. So NH2 is what? Electron repelling group. This SO3 is what? This is the minus M effect. Minus M group. So that the color is what? This is red. This color you have to remember. Whenever the phenol is there, diazonium salt, you will get what? Orange color. Wherever aniline is there, simple diazonium chloride, you will get what? Yellow color. This is giving what? Red color. Identify the correct statement about the alkali metals. The order of standard reduction potential. Sodium greater than rubidium greater than lithium. That is not correct. Cesium iodide is highly soluble in water. Generally, whenever you take this, okay, standard reduction potential, M plus M ion, this is wrong. Cesium iodide is soluble in water. Lithium carbonate is highly stable to it, wrong. Potassium dissolved in concentrated liquid ammonia, blue color, and paramag, correct. All the alkali metal hydrates are ionic solids, correct. Identify the correct statement about the alkali metals. Choose the correct answer from the... So generally whenever you consider this negative value, because always M plus by M means what? Reduction potential value. SRP values what? Reduction potential value the order of reduction potential value with respect to that one, with respect to sign. If at all you take the sign, then no problem. So now, so this is what? Whenever you see the sign, because the lowest value lithium, rubidium next, again this is the minus 2.71, this is the minus 2.93, this is 3.05, minus. This with respect to the sign, that reduction potential value order is the correct only. Cesium iodide is highly soluble in water. This is the cesium iodide because here cesium, cation and anion rate is also larger. So hydration energy is less. Hydration energy inversely proportional to radius of cation. So radius of cation, but little soluble in water, not high because iodide ion is there. Lithium carbonate is highly stable to it. That's wrong. Lithium carbonate on heating gives lithium monoxide and carbon dioxide because of high polarizability of anion, high polarizing power of cation. Potassium dissolved in concentrated liquid ammonia is a blue color and paramagnetic. So concentrated blue color, concentrated, it gives what? Branch color. So branch color generally what happens? It does not give. All the alkali metal hydrates are ionic. This is a A. So this is the A and E answers. If it is a potassium dissolved in liquid ammonia, simple liquid ammonia is given, then tell you what blue color solution, that is a solvated electron, that we can write the answer. But concentrated solution, ultimately it becomes what? Branch color. When branch color is there, all properties going to be lost. That's why paramagnetic nature is not there. That's why be careful. This is a very, very important good question. The hybridization and magnetic behavior of cobalt complex respectively. This is the D2sp3 diamagnetic, because here the strong field ligand is there. When strong field ligand is there, generally whenever you write, this is the cobalt plus 3, cobalt 27, generally what we write here. This is cobalt plus 3. I am writing dash. This is the 3D7, 4s2. So here 3D7, generally what I write here. This is the 3D7, 1, 2, 3, 4. 1, 2, 3, 4. This is again 1, 2, 3, 4, 5, 6, 7. Again this is there because here plus 2 oxidation state is there. That's why again I am removing this. Again this is also have removed. Then I am going to write. This is the what? So here, now I got, this is the one. Now here, this is a vacant orbital because plus 3 oxidation state. Now, here it is paid up. Now, this is going to be paid. So, the 3 pairs are there. Now, it is going to become what? 1, 2, 3, 4. 1, 2, 3, 4. So, here, totally there are 6 electron 3 pairs. Now, it has got 2 vacant orbital. This is a 3D level. That is the n-1 level, inner orbital. Then what happens? 2 electrons. Again, this is the 2 electron. 2 electron. Again, D 2 electron. D2 sp3. sp3 is there. So this is the D2 sp3. D2 sp3. hybridization. So D to sp3 hybridization, diamagnetic because there is no unpaired electron. Diamagnetic D to sp3 hybridization. Okay. K2Cr2O7 paper acidified with a dilute sulfuric acid turns green when exposed to carbon dioxide, sulfur dioxide, sulfur trioxide, H2SO4, sulfur dioxide, sulfur hydrogen sulfide, and sulfur dioxide. This is absolutely because of sulfur dioxide liberation. This is going to be happen. K2Cr2O7 paper acidified with the dilute sulfuric acid turns green when exposed to sulfur dioxide, because this is going to be giving K2Cr2O7. This is Cr plus 3. This is the green color, chromiums. So that's why it is a sulfur dioxide only, because it is acting as sulfur dioxide act as reducing agent. This is the plus 12, this is the minus 14, 12, again plus 6 to plus 3. This is the plus 3 electron. A direct question. The number of statements which are characteristics of the physis option is, it is highly specific in nature. It is not highly specific. It is non-specific in nature. Enthalpy of adsorption is high. Enthalpy of adsorption is low. It decreases with increase in temperature. This is correct only. It results into unimolecular. It is a multi-layer. No activation energy is needed, because activation is a very low activation energy needed. No activation. Low activation energy is needed. Only 2. No activation energy. This is the general what you have to write here. Low activation energy. Low activation energy. No activation energy. That is not correct. Low activation energy. No activation is needed means that also not correct. So here it becomes, if it is a low activation energy needed, that is correct. No activation energy needed, that is not correct. Some of the pi bonds present in the peroxo disulfuric acid, pyrosulfuric acid. This is the peroxo H2S2O8. This is H2SO5. H2S2O8, generally what is the peroxo? Peroxo, generally when peroxy bond is there, first we have to write peroxy bond. This is there, sulfur. When sulfur is there, generally what we have to write, again double bond, number of oxygen, number of oxygen, number of oxygen, number of oxygen, again OH, again OH. Pyrosulfuric acid. Pyro means general water removal. HO H2S2O7. Pyrosulfuric acid. H2SO4. Pyro. H2S2O7. Oleum. Maximum number of isomeric monochloro derivative which can be obtained from 2255 tetra methyl hexane 2233. Two, 3, 4, 5. tetramethylhexane. Right. This is a CH2, this is a CH2. Now, number of monochloride derivatives equal to number of types of hydrogen. Now, you find out the number of hydrogens, how many? This is the primary hydrogen. Vicinity of this. This is the primary. This is the primary. This is the primary. This is the primary. Primary. So, primary, 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 primary. All these primary hydrogens are same. Now, whenever I write this is there, if at all I write like this, CH2Cl, here CCH3, again CH3, CH2, CH2, CH3, CH3, CH3. Now, another junction, what is this is the one. So, if it was this cannot be, because whenever any one of the hydrogen same. Now, I am taking this. This is CH3. 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 CHCl. CH2. CH3. So, here this is not a chiral carbon. This is not a chiral carbon. What he has given? Number of isomeric monochloride derivatives. Now, generally what happens? Here this is the what? The chiral carbon. So, plus and minus. So, here generally 1. So, totally how much? You will be getting 3. Total number of tripeptide possible by mixing when valine and this is a 2 to the power of n. If at all you want, just follow the tripeptide. Number of amino acid, number of peptides. This is equal to what? 8. N is equal to number of peptide. This is generally what? N to the power of m. Whereas n is equal to number of type. The number of units which are used to express concentration of solution from the following is. So, mass percentage we can use mole, fraction, molarity, ppm for diluted solution, molality, 5. We can use 5 mole, not all these. The number of statements which are correct with respect to the compression of the carbon dioxide from the point A in the Andrews isotherm from the following, this is there. Carbon dioxide remains as a gas up to B. Remains as a gas up to B, correct. Up to here. Up to B, correct. Liquid carbon dioxide appears at point C. Liquid carbon dioxide, that is not correct. liquid and gaseous carbon dioxide coexist between point BC. These are correct. As volume decreases from B to C, the amount of liquid decreases. B to C. General what? Whenever it is there. Now, as the volume decreases from B to C. Volume decreases, this is what? Amount of liquid decreases, that's wrong. Okay. This aneurysm, this is nothing but what? Critical temperature. This is the temperature above which gas cannot be liquefied. This is all liquid phase. This is the equilibrium between gas and liquid. From here to here only liquid. Right? So only two are correct. Total pressure observed by mixing two liquid A and B 350 mm when their mole fractions 0.7, 0.3 respectively. The total pressure becomes 410 mm mercury if the mole fraction or the change to 0.2 to 0.8 respectively for A and B. Vapor pressure nearest integer considered liquid solution behave ideally. So according to the ideal gas behavior Raoult's law, then P naught, that directly we can do the problem like this. So I already have done. This is the let vapor pressure of pure A be P naught A. Let vapor pressure of pure B B. Now as you know that XA is equal to 0.7, XB is equal to 0.3. Pressure of solution is equal to 350. So P naught A 0.7 plus P naught B into 0.3 is equal to 350. This is 1. XA is equal to 0.2, XB is equal to 0.8. So this is equal to 410, right? Now generally we can easily do the same sequence. What we write here according to Raoult's law, P naught A into mole fraction plus P naught B into mole fraction is equal to 410. So then P naught A is equal to, by substituting 1 and 2, this is the 315 mm for pressure of A is 340. Work done. That is the A122 is ISO 1 mole of an ideal monoatomic gas subjected to changes as shown in the graph. The magnitude of the work done by the system on the system is a dash joule nearest integer. This is what isothermal process, this isochoric process. Again this isothermal process, this is a isobaric process. Now given log 2 is equal to n. Generally what we write here? See, this is again here also I did this same. This is a 1 to 2. This is isobaric. Isochoric. This is isochoric. This is a volume is a constant. Here pressure is a constant. So this is isothermal. Okay. So what we have to write now? W is equal to 1 to 2 plus W is equal to 2 to 3 plus W is equal 3 to 1. So this we can write minus P V2 minus V1. V2 by V1. That is equal to minus 1. Substitute the values. Minus 1 into 40 minus 20 plus 0 minus 1 into 20 into ln by 20 by 40. Minus 20 plus 20 ln 2 minus 20 plus 20, 2.3 into 0.3. This is minus 6.2. So this is calculation. This is how much it is going to be, around 620 joules. pK of lactic acid is 5. Then pH is equal to 0.005. M. Calcium lactate solution 25 degrees centigrade is dash into 10 to the power of minus 1. So how we can calculate? This is the lactic acid, this is the strong acid versus this is a weak acid versus calcium lactate, calcium hydroxide strong base, right? Now we have to do the problem how the concentration of calcium lactate. So what is the concentration of calcium lactate is equal to 0.005 molar, right? Then what he has given? So this is equal to 0.005 into 2 is equal to 0.001. 0.01. So the pK of lactic acid is 5, then the pH of 0.05, calcium lactate solution, because lactate I converted into normality because calcium divalent ion. Now lactic acid, it is a calcium lactate. Is strong base versus weak acid. Strong base versus weak acid, generally what? It is the more than 7. So 7 plus of pKa plus of log C. Then is 7 plus of 5 plus not 5, nothing but 0.001. 7 plus of 7 plus 85. Or directly we can write, this is the 7, only one step we can write. 7 plus of pK minus of pK plus of log C. Log 1 is equal to 0, that is the minus 1. This is the what, 2.5, 7.5. This way also we can calculate. Directly we can say that only I wrote. This way also we can write. Direct to only one step. Same, that only these both are same. Right. So it is going to be around 8.5, nothing but 85 into 10 to the power of minus 1. Following figure shows spectrum of an ideal black body radiation. Black body at 4 different temperature. The number of correct statement from the following is T4 greater than, T3 greater than, T2 greater than, T1. This is wrong. T1 greater than, T2 greater than, T3 greater than, T4 correct. The black body consists of particle performing simple harmonic motion. That is also not correct. The peak of the spectrum shifts to the shorter wavelength as temperature increases. Shorter wavelength. General what? Again, this is the correct. Shorter wavelength. The given spectrum could be explained using quantization of energy. Is it correct? This is quantum mechanics. The peak of the spectrum shifts wavelength, shorter wavelength, always as temperature increases. The spectrum of the black body is okay. The peak of the spectrum shifts toward the shorter wavelength, more frequency. This only correct. So according to this is the graph. These are only, they are correct. 2 only correct. Shorter wavelength means what? More frequency. Only these 2 are correct. This is not correct. V1 by T1 is Vt, T2 by V2 is equal to T3 by V2, not a constant. Complete.